used to do these. And it will say on the test, like, thou shall use polynomial long division, thou shall use synthetic division, or, other, you get to decide. So if you haven't done this in a while, it can be kind of tedious and frustrating. But with a problem like this, there's always the term that goes outside the house, or in this case, the divisor.
Right.
And the other thing, which is, what is that called?
The dividend?
Maybe that is right. The dividend, yeah, goes in there. The answer is the quotient. Yes, that does sound right. I never use these terms. You want to really, like, if you use those words around people, they'll think you're really a math guy if you use dividend and quotient, remainder, and divisor. So,
Right.
all right, so you start with this 5x and you say, okay, how many times does 5x go into 20x squared? And the answer is 4x. 4x times 5x is 20x squared. So that 4x goes above the x. Like, you think of these as columns, the x squared column, the x column, the number column. So it goes right there, 4x. Then you take the 4x and you multiply both of these. You multiply the 5x, then the minus 6. This becomes 20x squared minus 24x. Is that okay
Right.
up to this point?
Yes.
All right. Now, there's a lot of ways to do this next part. I think it's good to change the signs. There's one way I show students. So this becomes negative, this becomes positive, and then you're adding together. They do show subtraction in the textbooks, which is fine. It's also correct. You just got to be careful that you distribute that negative to everything, or you got to, recognize, because if the first one's always zero, like, even if you don't know what you're doing, most students are like, all right, I know it's zero there. But this next one could get out of hand quickly. Like, imagine if you go the wrong direction, it might not work. This becomes
Right.
minus 15x. There's kind of another thing to look for here, which is that whatever this is on the left, it better go into this. I mean, that's the way these problems are designed. They're not designed to be weird where, they don't divide unevenly. And, like, notice if we didn't do the right operation here, we ended up writing like minus 63x, 5x doesn't go into that. So that's not good. You bring the next term down. This is kind of standard for long division. You always bring something down. Then you restart. You say, how many times does 5x go into minus 15x? Minus 3.
Minus 3.
The reason it's negative, you're basically taking minus 15x and dividing it by 5x. There.
Right. Right. And then,
so now you got to multiply, and you rinse and repeat. Minus 3 times 5x, minus 3 times minus 6. Let me clear out a little room here. Minus 15x plus 18. And then again, I'm going to recommend that you change the signs. So plus, minus, then you're adding everything together. And this time it goes to 0. It does not always go to 0. It just happens to in this problem. So this is your remainder down here. This is your quotient. And like you said, this is your divisor. Sometimes they use R, Q, and D instead of the full words.
Q. I've seen the others, but I've never seen Q.
For quotient?
Huh. I guess that makes sense.
Yeah. I mean, so the reason I bring that up is your answer. There's two ways to write your answer. Way one is quotient plus remainder over divisor. And this is what I think is more commonly accepted. The second is quotient times divisor plus remainder. You sometimes see that in online tools, calculators.
Why would 2 make sense? Wouldn't that just be the polynomial itself, or the dividend itself?
It's the divisor, not the dividend. So it in this problem, these are just different ways to show it. This is the one I'm seeing that like go with this, but I'm just sort of showing this. Like sometimes you see this as well.
Okay. Hmm.
Yeah, let's just not even bring that up. So in this problem, there is no remainder. So 0 divided by anything is 0. So you just show the quotient. Like that's your answer.
Okay.
Any questions on that before we move on to 4?
No, actually.
Okay. All right. So you start with the 4t minus 5 on the outside. 4t cubed minus 17t squared plus 7t plus 10. And you start with how many times, or what do you, another way to say it is, what do you multiply 4t by to get 4t cubed? What do you
T squared.
t squared? So that goes in the t squared column. So t squared times 4t is 4t cubed. You're probably noticing a pattern. These always line up and match. T squared times minus 5 is minus 5t squared.
Hmm.
So
Wait. No, yeah, that makes sense. Never mind.
now you change the signs. So negative, positive, add them up here. You should always get 0 in the first position. Minus 12t squared. You kind of just check, like, does that work? Does 4t go into that? It does. That's good. Plus 7t. Okay.
Right. Sorry, I'm checking my work. I did something very wrong in class.
Okay. Yeah. Why don't you take a look at that and see what you come up with, because any mistake propagates through the entire problem,
Right.
which is awful. Like it's one of the worst things you could ever experience, and because you basically have to restart. They do some memes like that where it's like, how do you feel when you realize you made a sign error in the first part of your proof, and it's not real pleasant.
Not really.
It's like making you go on a road trip and you go going the wrong way, and you start out, you're like, man, one time I forgot my bags on a road trip. Like, had to turn around before I even got going.
What did I? Oh, okay. Never mind. I see it. Yeah. Okay.
Okay. So you restart here. You ask yourself, what do you multiply 4t by on the left here to get minus 12t squared? And you're going down, like it should be in the t column now. Should be. It doesn't, not always, but in this case it's minus 3t. Then you have to multiply both minus 3t by both of these. So that's minus 12t squared, which it's supposed to line up perfectly, plus 15t. And then you change the signs. Plus, minus. Add them up here. So you get minus 8t. Bring this down, plus 10.
Yeah, that makes a lot more sense.
Yeah.
I
So
had minus 22T.
yeah, and then that won't work because it doesn't divide in evenly. Now it doesn't have to, but these are all designed to work out nicely.
Right. Okay. Well, that makes a lot more sense.
All right, so how many times does 4t go into minus 8t? Minus 2. Minus 8t. I think it's plus 10.
It's 10.
change the sign, and you end up getting a remainder of 0.
Yeah, that makes sense. Because I was looking, in class, I was really confused, and I was looking at the answer and it said t squared minus 3t minus 2, but
Mhm.
my work said t squared minus 3t minus 2 remainder 30.
Yeah, and you just, like I said, any mistake goes through all the way.
Huh.
There's not really any intermediate checks either, unfortunately. It's kind of an all or nothing.
Yeah, it's. Oh, man. All right. Hold on. No,
What's that?
nothing.
Okay. All right, number 6. There's a couple of exceptions that we got to get to, but doesn't look like they show up, at least to start here. Why don't you try this one on your own? Um, I'll get the answer here on another screen, and you can ask me some questions just to see if there's any things that you don't know or aren't clear about. But I think this one works out nicely. Kind of has the feel of that.
Okay.
Yes, this one does have a remainder. That's okay.
Yeah, it'll be fine. Ooh, that's weird.
Let me put up a little bit here just to see if there's any issues. Should be 4x is your first one.
Yep.
So it should be minus 5x minus 1.
Yes.
Okay.
I think I got it.
Okay. So
Or,
this is minus 1. Did you have minus 1 here?
yes.
Okay, so that becomes minus 5x minus 2, but then you change the signs. That's why your remainder is minus 1. So the way to present your answer is the quotient 4x minus 1 plus the remainder in the numerator, and then the divisor in the denominator.
That's so weird, but okay.
There is a reason for this. There's something you'll be doing maybe in a few weeks here, week or two.
Interesting.
All right. Okay, let's do another one here. Sorry, I'm hemming and hawing. I'm just trying to see if there's something else here that I'm not seeing. Okay, so 8's finally a little different. The only kind of, you can divide by more And then just a linear term. This time you're dividing by a quadratic term. But it still doesn't change anything. You still put that x squared minus 3x on the outside, or x cubed minus 5x squared plus 2x minus 6 on the inside. So for problems like this, you generally are forced into using polynomial division. So you know, we could talk about why, but same process. You're trying to go from x squared to 4x cubed. You're trying to go from this one on the left to this one here. So that becomes 4x. So you take 4x and multiply each of these, the x squared and the minus 3x. So that's 4x cubed minus 12x squared. Change the sign of each. So that becomes 7x squared, bring one term down, plus 2x. All right, so then how do you go from x squared to 7x squared?
Multiply by 7.
Yeah, so plus 7, 7x squared minus 21x. So then you change the signs. So negative, positive, so this becomes 23x. 23x, bring this down, minus 6. So you're done. When you're done when you get a number in the ones position. Like that's for sure. You're done there. This is the remainder. Now maybe you're used to the remainder always being a number. The remainder here is an expression.
We can do that.
Yeah. All of this is your remainder. This is your quotient. This is your
That's
divisor.
stupid.
Yeah, well, these have different meanings. I mean, they're not really. They're just like, hey, we're gonna do some problems here. I mean, these actually have meanings graphically, but we're not doing any of that yet. But that's where I think you're going.
We're gonna do that on Thursday, he said.
Okay.
Okay.
Well, that'll help. To kind of have some context, like why are we doing this? And
Right.
so your answer here is the quotient 4x plus 7 plus, and you always put your remainder in the numerator, 23x minus 6 over the divisor, which is x squared plus 2x. But or x squared minus 3x. Sorry. Squared minus 3x. Grab the wrong. Okay. All right. 10's got kind of a little wrinkle to it that we need to talk about. I'm glad we're doing 10. You may have to, I think it's 10. You probably have to confirm what I'm gonna snip in because I don't, or is that a cube? I guess not. Okay, I take that back. We'll do that after these. So 10 is y squared plus y, and then it's 8y cubed minus y squared minus y plus 5, like that. So why don't you give this one a try? It's very similar to the last one. But we gotta do some of the exceptions, I guess. I see them finally. Yeah, why don't you try this, Joaquin, and let me know if you have any questions while you're working it out.
Okay. Um, So eight y. Yeah. Yeah, that makes sense. There's a remainder in this one, right?
Yes. Yeah, it's not this one does not work out nice.
So is it 8y minus 9 plus 8y plus 5 over y squared plus y?
Yes. Very good. All right. Might as well have you try 12 before we do some new ones. If that's okay with you, because I mean, you do seem to have it down. 12 is really similar to the previous one. It's just a bit more involved. A squared plus 3a minus 4, and then inside the house here is 5a cubed plus 7a squared minus 2a minus 9. So we'll do some synthetic division after this, but let me know if you got any questions
Okay.
as you work through this one.
Okay. That'd be okay. Uh, Simple math is failing me. Which would be minus 8, I believe. And then 8 squared. No, okay. Um,
How are you doing? I mean, I heard some of the right things. I heard 5a minus 8 at some point, I think.
yeah.
That's correct.
So 5a minus 8 with remainder negative 6a minus 23. So it'd be
Ah,
5a.
so close. Yeah. So there's some sort of mistake here. So let's go through the 5a. Excuse me, 5a cubed plus 15a squared minus 20a. You have to change the signs of everything. So that gets you down to minus 8a squared plus 18a. Does that match?
Minus 8? Oh, plus 18.
Plus
Yes.
18, yes. Then you bring down the minus 9. We already know it's minus 8, so that's minus 8a squared minus 24a plus 32.
Mm-hmm.
Change the signs. Got to change them all. So positive, positive, negative. First one's always 0. Second one is 42a minus 41.
Oh my God. Wait. That changes everything. Yeah.
I mean, you're done. You're down here, but you're the thing is you've got to like get it right. There's no like partial credit, there's you either have it or you don't. Because they don't
Right.
want to be chasing around sign errors. They don't want to be like, oh, where do you go with that? It's like, well,
Right. Yeah.
so your answer here is 5a minus 8 plus 42a minus 41 over a squared plus 3a minus 4.
Right. That makes sense. There we go. Okay. That's, I still think that setup's weird, but whatever.
Yeah, I don't disagree. I mean, it's not like we made it better. It's probably more confusing this way, but that is what it is. All right, so we've completed everything you wanted to work on, at least what you stated in your email. We can move on to synthetic division, which is in the next grouping of problems. There's also a couple of exceptions to long division that didn't come up in these that I would be worth showing you at some point. I guess I'd prefer to do that first, like a problem like 36 first,
Okay.
just to show you the exceptions and then move to synthetic division. Is that okay?
Yeah, that works.
All right. So in every problem we've done so far, let me actually show you that. In the dividend, it's in descending order: cube, squared, 1, 0. In this problem, cube, squared, 1, 0, powers of x. Same thing up here: cube, squared, 1, 0. We did a squared, power of 1, power of 0, and so on. In this problem, this is an exception. This is like what you'd see on the test, is they don't give you the x squared term, okay? And you can't just ignore it. You have to actually, and this is why it's test question, because you're supposed to remember that it's really 0x squared minus 1x minus 4 from this on the left. Okay, so if you don't do this, you get the wrong answer. You have to know if it's missing a term, and it could be a constant. If it's missing a constant term, you still put 0 in there. Power of x, you just put a 0 in front. Is it clear what I did there?
Yes.
Okay, and then this x plus 3 is still on the outside. Like that doesn't change. And so we work it from here. So it's 2x squared. Now here's what sometimes happens on the test is you forget to do this thing, and then you write 2x squared and you're like, where do I put it? And then you hopefully you're like, okay, well, there's nothing to line it up with, which means I should have had something there. So you end up writing it. Sometimes that happens. So this becomes 2x cubed plus 6x squared. Change the signs, negative, negative. So you end up getting minus 6x squared minus 1x tell me what goes up here next to the 2x squared.
Negative 6x.
Good. So you get negative 6x squared minus 18x. Change the signs. Bring that down. So then last part here, you got to figure out what do you multiply x by to get 17x? Well, that's 17.
Mhm.
Multiply them both, 17x plus 51. Subtract. You end up getting minus 55 as your remainder. This exception here, it applies to both synthetic division as well. But you do mainly see it in the long division problems. You see that they will omit a term or two. They can actually omit more than one term.
Right. I do remember him mentioning this in class.
Yeah, unfortunately, you do so many examples in a row where it just works. You forget to look for it. Like 43 is a great example of that because it's actually missing a bunch of terms. I don't know if you have that in front of you. If not, I'll snip it in. We'll just talk about it before we move on to.
Which one? 43?
Yeah, let me show you that here. So this is really x to the fourth plus 0x cubed plus 0x squared plus 0x minus 16.
Oh yeah, we did something similar in class.
Yeah. You got to get them all. You gotta get them all.
Yeah. Yeah, that was weird.
Yeah. All right, so we got some time left here. Should we do some synthetic division? Do you know which ones you might want us to do? Do you have another assignment or something else for us to look at? What would be best to help you?
I think synthetic division would be good to go over.
Okay, I'll do the well, you got all the answers. I usually just do the ones, but we'll because you don't have the answers, but I will do the even ones even though you have the answers. All right. So synthetic division here, and I show this as a box, even though it's not really a box. The number that goes in the box is what makes this equal to 0 on the right.
Right.
Okay, it's 1 because it's x minus 1.
It's the opposite.
Yes. Then you have to put the coefficients 5, minus 9, and 4. And like we've been talking about, if it's missing one, you have to put 0 in. You can't like think that it'll just be okay. You always bring down the first number. Always.
Right.
You take that 5 and you multiply it by the 1. Then you add. You always add in here. So this becomes minus 4. Then you repeat. Minus 4 times 1 is minus 4. You add and you get 0. This last number is your remainder. Okay. Now it was x squared. It was x, and it was the constant term. So when you divide, it goes down by powers. So this 5 is no longer the x squared. It's now 5x. It's no longer minus 4x. It's minus 4. So it goes from x squared to x, or let's say it was x cubed. It go down to x squared, and so on. And this is your quotient, by the way.
Right.
It sounds like you did some of these in class, maybe.
A little bit. Some of these were really confusing, but we did some of these in class.
Okay. Do you have these notes down? Because I'd like you to try 15 or talk me through 15.
I don't. Let me see.
We'll do it together. I just wanted to. You want to get this down? You can.
Oh yeah, no, I have them.
Okay. Here we go. All right. So again, the number that goes in the box is based on this on the right. What would go in the box?
2.
2. Then you write the coefficients, 4, -5, -6. What do you do with the 4?
You drop it.
You bring it down, bring it down.
Right.
And then 4, you multiply by 2.
Right. To get 8.
Good.
Then you
So then-
add 8 and 5 to get -3. Positive 3.
Positive 3, yeah. Then you take that 3 and you multiply it by the number in the box.
2 to get 6.
And you
And you
add
add that
again.
together and it's 0.
Yeah. So again,
So it'd be 4 plus 3.
well, it's 4. It was x squared, like this was 4x squared. So this is now 4x because you got to go down by 1 power when you divide.
Okay.
This middle one was x and this last one was the constant. So you go down by 1 power. So it's 4x plus 3 is your
I see.
quotient.
I see.
All right. Gotta have you try one here on your own. So let's have you try 17. This one does have a remainder of 0. So go ahead and set it up, work it out, ask questions or, just hope for the best, see if it comes out nicely.
Yes, sir. Is that x divided by 3 or x plus 3?
Plus 3.
Huh.
Yeah. So what number goes in the box in that case?
-3.
Yes. Good.
Oh man. Uh, no positive. X minus 7. 2x minus 7.
Let me check here. Yeah, you got it. Very good. Okay. Let's do some other ones here. Let's see. Looking for the ones you'll actually get on your test. So here's something else that they will do on a test. They'll do something like this. They'll give you, I'll say, all right, 4 minus 7x plus 2x squared plus x cubed divided by, let me see where I lost my place here, divided by x minus 1. Okay, so notice the dividend is not in descending order. The x cubed is all the way on the right here,
That's true. That's weird.
and that's bad.
I'm
Like,
backwards already.
yeah, it's just backwards. Now, but if you are not paying attention and you go, all right, 4 minus 7, 2, 1, 4, if you start doing this, this is wrong. This will not work. Now, it might work in a weird way. But you're not supposed to do this. It has to be in descending order. Okay.
Right.
So like the fact that this one worked, which I'm kind of shocked. I didn't think that it would just work out. There might be something to that. You don't want to do that. You want to rewrite x cubed. Sometimes it's good to write the coefficient plus 2x squared minus 7x plus 4. And you want to write those coefficients 1, 2, minus 7, and 4. Why don't you work this one out, see if it does work out nicely. I don't know if it does or not.
Yes, sir. Be So it'd be x squared plus 3x minus 4.
Let me check here. That is correct. Yeah. Is there any remainder?
No.
There's no remainder. Agreed. Okay, very good. So let's look at one of these sort of awful ones. Let's say you want to do x to the 5th minus 1 divided by x minus 1 using synthetic division. 1 goes in the box, okay? And then it's 1x to the 5th, 0x to the 4th, 0x cubed, 0x squared, 0x minus 1. So if you don't like that, if you're like, oh, I'm not sure I remember that, you can then write them out.
Right.
But if you don't do this, your answer is completely wrong. Like they're not, the teacher's gonna be so frustrated. Like, why didn't, he didn't pay attention in class. Like I told him this, that's why you gotta do it. It's more because it's like a frustration point for teachers. Because they really want you to do well. I mean, I would think in general, but this one, okay, so you bring the 1 down. 1 times 1 is 1, add it up, you get 1 again. Okay, it's not very exciting, but this is what it is. And you get a bunch of 1s in a row here. Yeah, I know, it's like why is this? So there's actually, there's actually something to this, and this is how people have found like patterns and how to formulate these, as they notice stuff like this. So it's
Isn't
kind of
that-
cool.
Sorry, continue.
I was just saying it's kind of cool, like that it's always 1. It's always that number in this case. Like, and then you might wonder, well, like if I change this to 32 and I make this a 2, does it then also work out like kind of the same pattern? That's how like people distinguish these things. There's beauty in numbers in some ways. What were you gonna say?
Right. I was gonna say, wouldn't the answer to this just be x factorial?
So x factorial, you gotta be careful with that. That means x minus 1, x minus 2 forever. And does that actually add up to a fixed polynomial? No, it does not. Like you really want it to, and it's kind of close, but no, it's not. It's not. So it's like, all right. So no, this is 1x to the 4th plus 1x cubed plus 1x squared plus 1x plus 1 remainder of 0.
Huh.
So in the limited time we have left here, let's have you try one for us. I'll just make this one up here. X cubed minus 8 divided by x minus 2. This one's very similar to what we were just doing.
Yeah. Positive 2 on the side. And then 1, 0, 0, -8. Excuse me. Oh my God. Bringing one down. 2 times 1 is 2. No, that's 2. And that's 4. And that's what? 4. Yeah, I can't. 8, 0. It'd be x squared plus 2x minus 4.
You're adding that last one there, right? So it should be
Plus 4, right?
plus 4, yeah. So x squared plus 2x plus 4. All right. Well, I think you got a good kind of a overall look at polynomial division here. Hopefully